Tony. I was fairly sure Tony only checked in to let us know that he was there. The next real questioner is Steve, KC2MDP. And Steve, I'll discuss anything except antennas. What would you like to talk about? I'm having fun with Steve. He does a lot of antenna experimenting. KC2MDP, K2RW. You got it, Steve.
Okay, Dick, thank you very much. And, yeah, you should get the Academy Award for ham radio, Dick. I have a question. It's, not ham radio related, but it is RF related. I'll throw this one basically out to the net. I don't know how knowledgeable you are on this subject, but it's, on smart meters. Anything you can tell me about, the electric meters, the smart meters, as far as RF-wise? I've heard so many conflicting stories about these things, and, you look on, like, YouTube and all these websites and everything, and these things got people quite scared, with the RF that's supposedly coming out of them. And, just any information you can give me, what's the power output, what's the duration cycle of these things, stuff like that. Back to you, Dick.
Okay, a smart person knows something about what he doesn't know. Give us a few words as to what is a smart meter. I sense that it is a fairly newly introduced product of some kind. How is it advertised, Steve? What does the manufacturer claim it can do? Roughly, what does it cost? So before we get into the specifics of whether or not it represents a radio frequency biohazard, I'm pretty sure I know what the answer to that's going to be. If it's being manufactured and sold in the United States, it's going to have to meet some reasonably strict rules with reference to a specific absorption rate, power flux density, and so on. So we can discuss those issues, but make believe I'm hearing the word smart meter for the first time. From what you know, Steve, what does it look like? How big is it? What is it intended to do? KC2MDP, K2RIW, the Tech Man.
Okay, Dick, it's basically an electric meter. You got your old single stator meter out to measure your kilowatt hours. This is new, it's all digital, and basically it supposedly, from what I've read, and I've read so many different things, but I'll give you what basically what the ARRL says on it. It's basically it's a digital meter, and it puts out an RF signal, and it puts out basically like an RF pulse every 15, 20 minutes, and it's on a 902 band, or it's on, I think it's on like 2.4, somewhere in that area. It says basically the meter is an average of 1 watt. I've read stories where people say these things are putting as much as 4 watts out. So basically it's an electric meter. They take the old meter out to replace this thing. It sends an RF signal. That way basically they don't have to send a guy to read the meter. Back to you, Dick.
Now I'm getting the picture. So it is the watt-hour meter on the outside of your house, which is now operating wirelessly. And there's a good chance, in my opinion, it's operating on either of those 802.11-like frequencies, 915 megacycles, 902 to 928 inclusive. And I've now spent the last 10 years of my life working on handheld RFID readers or interrogators that use that exact same band, the exact same frequencies, the exact same powers, and the 1 watt versus 4 watts and so on. I'm pretty sure I can explain this to you. And in the case of handheld RFID reader, there, in many cases, it's got a directive antenna which you aim at the radio frequency ID tag, and it sends a signal to the tag that gets rectified. The rectified signal becomes a DC voltage on a capacitor. The capacitor becomes a temporary battery. The battery runs the integrated circuit chip, and the integrated circuit chip then spits back a 96-bit code. Lots of information. Let me drop. Now, in order to meet the FCC requirements for license-free 902 to 928 megacycles, for instance, and that's, in my opinion, the most likely frequency region they're using, the FCC allows you to run as much as 1 watt, nothing more. if and only if you're on a pseudo-random sequence where you hop roughly 50 channels between 902 and 928 in a pseudo-random manner. So you're doing this random hop, and you're not dwelling on any one frequency for more than a few milliseconds. And the reason for that is because in the old days there used to be cordless telephones on fixed channels somewhere between 902 and 928 megahertz. And by way of this random hopping around, the person almost doesn't know. Occasionally he'll hear a click, but it doesn't even interrupt a symbol, a syllable of his conversation that he might be having on his cordless phone. So it's a way of sharing this frequency among a whole lot of license-free services, and everybody doesn't get interfered because of this random hopping sequence. Let me drop.